Hi, it's Mr. Benson here with a video on determining linear rules. So this is part D of chapter 7. Now, firstly, just thinking back to what you've been looking at, so the parts of a linear equation. Now, in the standard form, we've got y equals mx plus c. Now, m is the gradient, so it tells you the slope of the line, and c is the y-intercept, so it's telling you where the line cuts the x-axis. Now, if you know those two things, so those two numbers, then you know everything about a linear equation. So basically, when we say determining a linear rule, which is also called finding the equation of the line, all you need to find is the gradient and the y-intercept. So what we're doing is we're looking at a line and trying to figure out those numbers. So here's my graph. Now I'm going to have a look at this graph and see what I can figure out from it. Now remember, we've got to calculate the gradient, which is the slope of the line, or the rise over run, and we've got to calculate the y-intercept as well. Now in this case, we'll start off with the gradient. Now when you're looking at a graph, sometimes the gradient is quite obvious. So if I pick this point down here and this point up here, where the graph appears to be crossing or intersecting with these lines on our grid, then my rise is this distance up here, excuse the wonky line, so that is a rise of +5, and the run across here, also very wonky, is a value of +4. So our gradient is rise over run, so in this case it is 5/4. Now remember that we sometimes want to calculate this in a slightly more mathematical way. It may be that you're just given some numbers, or it may be that the graph is not particularly obvious what the run is, and so we often want to calculate it instead. So the way we do this is we're actually thinking about the values of the coordinates. So this one is at 1, 2, and this one is at -3, -3. Now when we are calculating it, what we need to do is label these two. Now I'm going to call this my x1, y1 pair. Now I do this so that this is always the left hand pair, and so this is going to be x2, y2 over here. So always work from left to right. It makes the maths a little bit easier. So writing it the long way, now the rise is the change in y values, so it's y2 minus y1, and the run is the change in x values, so x2 minus x1. And working from left to right like that always means that you're going to end up with a positive number on your denominator here, and that just makes your life a bit easier. So 2 minus -3, be careful with your directed numbers, over 1 minus -3 equals 5/4. So that's the same thing. Now in order to calculate the gradient, now I've already mentioned, I think a couple of sections ago, how you need to do this. In this case it's not obvious, so I can see that it's somewhere around 3/4, but I'm not exactly sure what it is, so I do need to calculate it. Now the way to do it is you write down the equation as far as you know it. So at this point we know, that should have been a 4, we know that the gradient is 5/4, but we don't know the y-intercept. So we can write y equals 5/4 x plus c. Now we do know some y and x values, so we know that there's -3, -3, that's one coordinate, and we also know 1, 2, that's another coordinate. So what I'm going to do is substitute a y value and an x value in here from one of these coordinates, and I'll see what the y-intercept is after I solve it. Now I'm going to choose the 1, 2 coordinate. I suggest you do the one that has positive numbers in it where possible. It just makes the maths a bit easier. So I'm going to substitute my values. So y is 2, x is 1, and then all I have to do is solve this equation. So 2 equals 5/4 plus c. c equals 2 minus 5/4. which equals 3/4, which was a good guess at the start. So now I know the two things about my equation. I know my gradient of 5/4 and I know my y-intercept of 3/4. So in this case I can write my linear rule is y equals 5/4 x plus c. And I recommend that you do write it in this way where the gradient, whether it's a whole number or a fraction, is in front of the x value. So I wouldn't write it 5x/4. I think it's just a little bit clearer if you write it this way. Now, moving on to another example. Sometimes the y-intercept is given to you. Now, it might be given to you in the form of a graph like this, because if you look here, you can see that this is crossing where y equals 1. So the other way of thinking about that, and the other way this information might be presented to you, is you might be told that the coordinate is at 0, 1. Now, obviously we'd have to go about working out our gradient the same way that we did in the previous example. Now in this case I can see that we're going across there and up here. So rise is 4, run is 3, and we could calculate this just simply as our gradient is 4/3. Now we could then go and substitute in values to find our y-intercept, but we don't need to do it because it's right there in front of us. So in this case c equals 1, so my equation is therefore y equals 4/3 x plus 1. Now any time that you get something like this where it's the line is crossing the y-axis at a point that is very obvious, they're giving you the y-intercept. Or if you're given a coordinate like this where the first value, the x value, is 0, now that is telling you the y-intercept, because when x is 0 you are on the y-axis. So either of these, they're giving you the y-intercept and you don't need to calculate it. And as I've shown you before as well, sometimes you're just going to be given a pair of coordinates, so there's no graph in front of you. So you really just need to approach this using the formula that I've used before. So this is where m equals y2 minus y1 over x2 minus x1. Now remember that you want to try and label these properly. So I've been a bit tricky in this example. I have shown you this example before and you might recall it. This x value of -3 would actually be to the left of the other one. So if we were to plot these on a graph, this coordinate would be drawn first to the left and then this would be off to the right. So I'm going to call this x1 y1 and I'm going to call this x2 y2. Then I'm going to do my calculation, and so what have I got? 10 minus 5 over 2 minus 3, and I get 15 over 5, which equals 3. So I've got a gradient of 3. Now if I had got these the wrong way around, it still would have worked. What would have happened though is I would have had negative numbers on both sides, the top and bottom of my fraction here, and they would have cancelled to give me +3. The thing with that though is a lot of people struggle with negative numbers and tend to make mistakes more often, so if you can avoid them, that's often a good thing. Okay, once we know this, now like I've said, I'm going to write out my equation as much as I know it so far. So I know my gradient is 3, so this is all I can write. Now I'm going to choose a point, a coordinate that I'm going to substitute in. As I've said before, choose the one with no negative numbers in it. That just makes your life a bit easier again. So substituting my values, 10 equals 3 times 2 plus c. Solving by taking the 6 over the other side of the equation, c is going to equal 4. So the linear rule for this one is y equals 3x plus 4. And as I've said before, When you're finding the y-intercept, just remember that it is where the graph crosses the y-axis, and it is often given to you quite clearly, either as the graph obviously crossing the y-axis on a point that you can easily figure out, or when you're given a coordinate like, say, 0, 5, this 0 here as the x value is telling you that you're on the y-axis, and so 5 must be the y-intercept. And remember also for linear rules that there are the special cases of vertical or horizontal lines. Now if you've got a vertical line, it's always going to be in the form of x equals something. Now whatever the x value that this is going through, so this might be x equals 2. Horizontal lines are always in the form y equals something. So you just need to look at where the line is cutting the y-axis, and that is your value.